Welcome to our lesson 3 on terms used in refraction on plane surfaces. Terms used. So we are going to use this diagram here. I have tried to draw for you. This is medium 1, this is medium 2, and this is the incident ray. Okay, where it touches the boundary between air and water. For example, this point is what we refer to as the point of incidence. So at that point, we normally draw a normal, a perpendicular line. Remember, already boundary is straight. This boundary is straight. So at this point, you can draw a normal. And that is how it got its name, perpendicular. Okay, so incident ray is a ray that goes to the boundary. Okay, at the point where it touches the boundary, otherwise known as point of incidence, we draw the normal. So once you draw the normal, to come even to the second medium. So from the first medium to the second medium. I've shown it in black, okay? Now, angle of incidence I is the angle between incident ray and the normal. Okay? And when we have refracted ray, then it forms angle of refraction between the refracted ray and the normal. So you have, this is the incident ray. At the point where it touched the boundary, which we call point of incidence, you draw the normal. The normal which we draw should not be on only one medium. It should be on the two, from one medium to the second. Always. Then we have what maybe you can take note of, the extent of bending. When ray is moving from less dense to optically dense medium, okay, from less dense to optically dense medium, what happened? So let me focus a bit down now. That's good enough. I think we can, yes. When ray is moving from less dense, like from air, to optically dense medium, what happened? The ray is refracted towards the normal. The ray is refracted towards the normal. So you better get that right. The ray is refracted towards the normal. In other words, the ray cannot continue on a straight line. Why? We are studying refraction. And from lesson 1, you remember, it can only move in a straight line in a homogeneous optical density medium. Homogeneous, made of the same. Okay, homogeneous, made of the same. So when it is homogeneous optical density medium, then the ray moves straight in a non-uniform. When you have situation where you have, like here, air and water is non-uniform. Air, its optical density is different from that of water. So it cannot move in a straight line. Okay? It will change direction, which is the essence of refraction. Now, if I reversed now, this is what you should do on your own. So if you reverse, this ray should not now look like that. Okay? What I mean is this now. This is incident, that. Now, if you changed this arrow to face up and this one to face that side, you should be able to now write on your own the second sentence. This one you will do on your own. When ray is moving from dense, now we are talking about dense to optically less dense. So I've changed. Here it was less dense, here it is dense. Now we are doing the reverse. Here it is dense, and this one is less dense medium. The ray is refracted, blah blah, normal. So I want you to think about this. What will it be? What will it be? And that is what we call law of reversibility of light. Okay, I want you to just do that. It is not difficult. We just change the words. You take the opposite. Okay, so that is what you need to know. The normal line to the boundary at the point of incidence is a perpendicular line. When this ray comes and touches the medium boundary, okay, now we don't have a homogeneous, kwa sababu tuko na hewa na maji. It's not homogeneous, okay, even vitu viwili tofauti. And when we say optical density, do you remember? Optical density, tunaangalia mambo ya the absorption of light and transmission. The absorption and transmission. The intensities of absorption vis-a-vis transmission. Ndio mambo ya optical density. Kidogo tofauti na density ile umesoma form 1. Maana ya form 1 tunasema density is mass over volume. Lakini unaposikia mambo ya optically dense or optically less dense, optical density ni mambo kidogo ya light, how light gets into material and how is transmitted. Now back to this, okay, back to this. The normal line is a perpendicular line at the point of incidence. A perpendicular to what? For us to talk about perpendicular, there must exist two lines which make an angle of 90 here. So the first line is the boundary, because you are talking about two mediums. Air, water. Two mediums. Air, water. So mahali zinakutania ni straight line. Then at the point of incidence, you draw the normal or a perpendicular line. It is famously known as normal. Okay? Now, laws of refraction. Laws. There are two laws. Law number 1. The incident ray, refracted ray, and the normal at the point of incidence, they lie on the same plane. They lie on the same plane. They lie on the same plane. The incident, see, I have the incident here. Then, for example, I've drawn the normal. I've drawn the normal. This is my normal, this is my incident. And this is my refracted. So these ones make the same surface. They lie on the same plane at the point of incidence. They make a single surface. Okay? If I did this, they are not on the same plane. If I did like that, they are not on the same plane. But if I did this, you can see, you are seeing like one surface. Okay? That's what it means. Then the second part of the laws of refraction pertains to, if I focus down, it pertains to the angle. So this is the ratio of the angle of incidence to the ratio of the angle of refraction is a constant. This was studied by Snell, and in honor of his work, it is also known as Snell's law. This is also known as Snell's law. That Snell's law states that the ratio of the angle of sine of incidence to the sine of the angle of refraction is a constant. Okay? So this is Snell's law. This is what Snell studied, developed this relationship. Okay? In this lesson, you need to know what is a normal line, what is the incident ray and incident angle, what is reflected, not reflected, refracted ray and refracted angle. You need to know the law of refraction. Maybe I can say the laws of refraction. There are two. One deals with incident ray, refracted ray at the point of incidence. When we have the normal, they lie on the same plane. The incident ray, the refracted ray, and the normal at the point of incident, those three lie on the same plane. Okay? Then the second law is also known as Snell's law, which states the ratio of the sine of the angle of incidence to the sine of angle of refraction is a constant. Folks, I think we can focus there. You have the terms used in refraction known. We have the laws known. The next lesson, we shall be dealing in details with Snell's law. Okay? In details, we shall be dealing with Snell's law. So try to get through this and tell your friends there is something that will help you. Don't give up. You are facing an exam. Everyone did the exam. You will pass if you put in the right effort. Please tell others to subscribe. We keep on sharing the little we can. Bye bye. See you later.